going to have Francesco Galareta. He's a data genius, and his presentation will be very interesting. So let's take 5, and we'll get back in 11:35 Eastern.
Thanks so much for joining, Francesco.
Yeah. Okay. Well, thanks for having me here, and it's a pleasure to share a bit some thoughts regarding no-code and low-code platforms, and of course, some of the learnings that we had and our experience at Intrepid AI, which I will take it as a reference just for the sake of the conversation. Well, before entering a bit the details of this relatively short speech, I think it's wise to make a distinction between indeed low-code platforms and no-code platforms. And though this difference, to a human being can be quite blurred, so to speak, the technology behind can be consistently different. Of course, they both, provide capabilities for end users to write pretty much no code or much less code than they should. And of course, with these technologies, end users can basically create applications that do not require a lot of hand coding intervention, so to speak. Now, there are some features that are kind of common to low-code and no-code platforms. For example, the presence of some components that are reusable, pre-built, and the classic interface of having an editor or a space where the user can drag and drop some nodes or whatever, modules that basically represent some basic skills that users can mix and match to create more sophisticated applications. But then, of course, when it comes to the no-code platform, the no-code solution, there is a much big difference behind the curtain, because these interfaces usually have to be much more intuitive. There is a massive presence of templates due to the fact that the end user cannot add code at all. So this is kind of an extreme, in my opinion. And as I will explain in a couple of slides, it also raises some concerns when it comes to, for example, flexibility and performance. With this said, of course, with this very generic distinction, we definitely have to say that both low-code and no-code platforms contribute to the so-called democratization of application development, meaning that not only power users, we call them, users who know how to code, but they want to speed up the process of building applications, but also business users still have a role, and an important one, in the workflow of building applications. So business users are basically those users who are not familiar with, of course, programming languages, and they don't have to be. Their business is being kind of at a higher level of abstraction of the business, but they still want to contribute and interact with the business at a lower level than their role. And so for these particular figures, low-code and no-code platforms are pretty much essential, in my personal opinion. We can move to the next slide. So, as I said, I will take the experience at Intrepid AI, which is my last startup that I created 11 months ago, that essentially implement, it's an example that I will use just to explain some concepts and also what we realized, what we found while we were building a low-code platform. For the record, Intrepid is an AI-powered all-in-one platform for autonomous robotics that essentially allows users to prototype simulate and deploy solutions for drones, ground vehicles, and satellite applications. Now, of course, users can be roboticists, so expert users, or they can be users who just know how the robots should behave, but they never programmed the robot in their life. And so that's a very nice example, in my opinion, that shows exactly what I was explaining in the previous slide. And of course, all these concepts that I will explain in a second can be definitely applied across diverse sectors, many other sectors, and not just robotics or artificial intelligence. In the next slide, I will explain a bit some of the trade-offs that users and designers have to deal with when they decide to move to a low-code platform or to a no-code platform, which is flexibility. Now, I have a formula, which is not really a formula, but it's kind of a trend on a hypothetical diagram, in which basically you have a line that goes from no code to a lot of code on the horizontal axis, and from low flexibility to high flexibility on the y-axis, on the vertical axis. So basically, to say that the less code you let users type, the less flexibility you usually get. So low-code platforms might mean also less flexible platforms if they are not designed well. And this is normal because you're changing the tools. You're removing the code out of the equation and asking the users to build applications without code. So of course, it's like asking a runner to run without a leg in a way. So when you change the tools, you have to kind of redesign many aspects of the platform in order to increase that flexibility that you are losing just because you're changing the tools. And by design, low-code platforms are usually less flexible than pure code, like platforms where you have to write code. And writing code is probably the only tool that you have to build that application. Another thing that is very important, and we found, again, while developing Intrepid, was performance. When you have a low-code platform that is badly designed, you kind of force the end user to, let's say, create things in different ways that were not meant to be. And this usually means degrading the performance of the platform. So I was still on the previous slide, but you can stay there. So this is, in fact, in order to overcome some of the limitations that I mentioned about flexibility and performance, these are some of the, if I can say, best practices, even though that would be a big word. But let's say we paid attention to some aspects of, let's say, a low-code platform design. And at Intrepid, we have this graph that you see here in this looping video, where essentially, the user is, in this case, dragging basic skills, essentially, which we call nodes, connecting them together, mixing and matching in order to build a more sophisticated behavior, which in this case is an orbit follower, basically a robot that follows an orbit trajectory. If you want to do this with code, it can be a lot of code, of course. While in this case, we can see that it's less than a dozen nodes, as you can see, and they are all part of the library. The problem is that you have to make sure that these low-code platforms are how we call Turing complete. So Turing completeness is a formal requirement that makes sure that you can build whatever you want, pretty much any function. I'm oversimplified. My old professors at university will be really mad at me if I define Turing completeness in these words, but this is not academia, so I have to go slow and easy. But essentially, Turing completeness is an essential formal requirement of pretty much any programming language. And so when you move from a programming language to a low-code platform, you want to maintain Turing completeness, which means that the representative power that you had with the programming language must be preserved on the low-code platform. If that's not the case, the low-code platform is less powerful than programming languages, and it would do much less things than a programming language would do. And that's why it's a very important requirement. Another thing that we learned from Intrepid is that absolutely no-code platforms are kind of, I wouldn't say to avoid, but very close to that statement, due to the fact that users, even those who are not familiar with coding, will always require some form of flexibility in redefining the node, some skills, or what we call nodes, their way. And so the possibility to implement the logic of a single node that you see here in the picture, in the video, with, in a fully template fashion, or in a fully code fashion, or in a mix or a combination of the two. And of course, if users cannot write, cannot read code, don't even feel comfortable with their background, which is normal when they are not senior developers, well, then they can just use templates, which are gently provided by the low-code platform developers. In the next slide, I want to make sure that the big trend of large language models that we all know, it's no longer news. I don't see why large language models should not be integrated with the low-code platforms, obviously. In fact, there are very interesting findings that we learned from the Intrepid AI experience. To start with, all low-code platforms, new generation low-code platforms, in my opinion, should be integrated with large language model or large language models or AI algorithms, from the AI field, to a certain extent. Now, at Intrepid, we pretty much designed a very interesting, of course, I'm biased, AI assistive technology that provides support to the user during the design phase. So while the user is creating that graph and putting together all these nodes and connecting them and mixing and matching, providing support in the form of a generative AI. And in the next slide, I can show you how that happens. If you click play on that video, hopefully you have enough rights.
I don't have access to do that. I did request.
That's a pity. Maybe I can. I didn't receive a request, but yeah, a pity. Anyway, basically, I will try to describe. It's a text form a la ChatGPT, in which you can define your scenario in plain English, and quote unquote magically nodes start popping up in the on your screen in your editor, and eventually the artificial intelligence can even connect them together if, of course, we have enough confidence about that type of connection. So basically building the execution graph that you saw two slides ago automatically. And we found interesting things happening there. In particular, the fact that integration with large language models, low-code platforms, and large language models seems to be much more straightforward than integrating large language models with code. For several reasons, of course, this stage is too short for me to explain the nitty-gritty of why is that the case, but please believe me and consume this statement and trust it. Now, of course, for the end user, what happens? It happens that instead of dragging and dropping and connecting nodes one by one, they can define their scenario and their application in the most natural ways, like language, and get, I'm not saying 100% of their application of these low-code nodes connected together, but even a 50%, let's say, which is kind of a worst-case scenario. Even a 50% of the nodes automatically and correctly generated for you, just from a bunch of lines in plain English, would save you 50% of the time dragging, selecting, and dropping and connecting all these nodes one by one. So you definitely increase productivity. And we found that this generation is apparently much more accurate than generating code. So letting the large language model, the LLM, generate pure code with respect to generating some kind of more constrained thing that is the language spoken by the low-code platform. Another thing that we found is that low-code platforms come with, let's say, reusability by design, which means that thinking about a modularized platform or a modularized application, it is much easier to do so with a low-code platform than with pure language. And that's extremely important for maintenance and reliability, correctness, and many other good properties that you definitely want to have in your application. So finally, to conclude, in the next slide, I have some envision the kind of future trends and possibilities, and kind of summarizing what I explained today. The democratization of application development is definitely one amazing property that low-code and no-code platforms are driving us towards, making application development more accessible even to non-technical people. That comes, no-brainer on that. Integration with cutting-edge AI technology, and in particular large language models, seem to be more straightforward and easier with respect to pure or full code platforms or only code platform. We have to define them somehow, or traditional platforms. Finally, also thinking in a modularized way, in a modularized fashion, increasing collaboration, expanding the ecosystem in a modular way, it comes easier with low-code platforms by design with respect to full code solutions. Of course, I probably just scratched the surface, and I hope I did a decent job explaining a bit how we took advantage of the low-code paradigm in our use case. Thank you.
You did a great job, Francesco. Thank you so much.